Hello everyone, welcome to our first lesson in chemistry, and we are focusing today on organic chemistry, to be specific, organic reactions. A couple more videos will come where we're going to focus on other aspects of organic chemistry, but in this one we're focusing on organic reactions. Now there are 5 organic reactions that we want to look at, but in this video we're going to look at one of the 5, and then we'll see how we can combine the other types of organic reactions. So here are the 5 organic reactions. It's called the first one, 1.1. We have combustion. 1.2, let's say elimination. 1.3, addition. 1.4, substitution. 1.5 is esterification. So this is our page 1. Now, like I said, today we're going to look at combustion only because it's a bit vast, and then we will look at other reactions. We'll see how we can combine these other reactions. I'm planning to have a minimum of 3 videos to complete the entire topic of organic chemistry. Now let's look at the first one, which is combustion. So 1.1, combustion. Combustion is also known as burning. Let's define it. We define combustion as a chemical process. Definition. Combustion is a chemical process in which a substance, any substance, reacts rapidly with oxygen to produce heat energy and light. So combustion is defined as a chemical process in which a substance reacts rapidly with oxygen to produce heat energy and light. So we have 2 types of combustion. Types of combustion. We have 2 types. Number 1, complete combustion. What are the properties of complete combustion? 1, it takes place when there is excess oxygen. So complete combustion takes place when there is excess oxygen. What is the other property of complete combustion? It produces a blue flame. This is how you would identify it in the laboratory, for instance. If you see that the flame produced is a blue one, you know there's complete combustion taking place. What is the other property of complete combustion? Its products are water and carbon dioxide if the substance that reacts with oxygen, let's go to page 2, page 2, okay, here we go. If the substance that reacts with oxygen is an organic compound. So we're sure that if the substance reacting with oxygen is an organic compound, the products will be carbon dioxide and water if the combustion is complete. Let's look at type of combustion number 2, incomplete combustion. What are the properties of incomplete combustion? 1, it takes place when oxygen is in short supply. Or when oxygen is insufficient, or when oxygen is a limiting reactant or reagent. Condition number 2, how would we identify incomplete combustion? It produces a yellow flame. This is in direct contrast with complete combustion, which produces a blue flame. What is the property number 3 for incomplete combustion? Its products are either water and carbon monoxide, or water and soot, which is basically carbon. So this is how you would identify the two types of combustion. Complete combustion takes place when there's excess oxygen. It produces a blue flame, and its products are water and carbon dioxide if the substance reacting with oxygen is an organic compound. Now, type of combustion number 2, incomplete combustion, it takes place when oxygen is in short supply. We also know that it produces a yellow flame, and its products are either water and carbon monoxide or water and carbon or soot. Now let's look at the reaction condition then for combustion. Reaction condition. We understand that we need a fuel and oxygen, but we also need, this is a special one, we need heat energy to raise the temperature of the fuel, which we call the substance in the definition of combustion there, of the fuel, let me put substance in brackets, to or above its ignition temperature. That's the reaction condition, the major one. Of course, like I said, we need a fuel we need oxygen, but we also need heat energy to raise the temperature of the fuel or substance to or above its ignition temperature. Right, so next I want to look at, so all combustion reactions need that condition to take place. Right, next I want to talk about balancing combustion reactions. So I'll start by looking at alkanes. How we balance alkanes is exactly the same way we balance alkenes and alkynes. So I'll give two examples on alkanes, and I'm going to move on to alcohols, carboxylic acids, ketones, and esters. Right, so let's look at examples then. Examples. So the information, the question is balance the following combustion reactions. Right. So my example one is going to focus 1 and 2. We'll focus on alkanes, like I said, and the explanation I'm going to provide for alkanes, balancing of combustion of alkanes, you use the same explanation for balancing of combustion of alkenes and alkynes. Now, number one, let's say we have C3H8, that's an alkane, because it obeys the formula CnH2n plus 2 of all alkanes, the general molecular formula. Now it's combustion, so we're reacting this with oxygen, giving us, because we want to talk about complete combustion, it's going to be carbon dioxide plus water. Now, I want to talk about number 2. So take note, the number of carbon atoms here is an odd number, and I want to give an example where the number of carbon atoms is an even number. Let's say C4H, 2 times 4 is 8, plus 2, that's 10. And that's butane right there. Combining with oxygen, again, in a complete combustion reaction, the products would be carbon dioxide and water. Now let's see how we balance these two. So these two are both alkanes. What I'm going to explain here, you apply the same for alkenes and alkynes. Now let's look at the answer. Number 1, C3H8, propane, reacting with oxygen, giving us carbon dioxide plus water. Now, so what do we say? We say, let me use a red pen here. We say there are 3 carbons here. 3 carbons, and therefore I need a 3 here to balance the number of carbons on the right hand side. Next, we're moving on to hydrogens. Moving on to hydrogens, there are 8 hydrogens here. I need a 4 here to balance the hydrogens, so that here I said we need 3 because you have 3 carbons here. 8 hydrogens, 4 times 2, 8 hydrogens. And oxygens, we go to the right hand side first. 3 times 2 is 6, plus 4 times 1, there's a 1 here, remember? Water, you can also write it as H2 or 1, but we do not indicate the subscript 1. So there are 4 oxygen atoms there. Now what is 6 plus 4? The answer is 10. And then we're going to take 10 divided by this 2 here. Our answer is 10 over 2, which gives us 5. That number there must become the coefficient there. This equation is balanced. We can check it. 3 carbons, 3 carbons. 8 hydrogens, 8 hydrogens. 4 times 2 is 8. 10 oxygens, 5 times 2 is 10. 3 times 2 is 6 plus 4, 10. So the whole equation is balanced. Let's move on to the next one. The next one is number 2. We have C4, H10, butane, combining with oxygen, giving us carbon dioxide and water. Let's balance this. So we have 4 carbons here. We need a 4 here, 4 carbons. We have 10 hydrogens here. We need a 5 here to make it 10 hydrogens, because 5 times 2 will be 10. For oxygens, like I said, we start from here. 4 times 2 is 8, plus 5 times 1 is 5. And the answer is 13. Remember, in our step number 1, number 2, we're dividing this number, 13 all over 2. Now this must come here. But we do not leave the answer with fractions. So I have to multiply this by 2, that by 2, that by 2, and that by 2 to get rid of the fraction. So therefore, our balanced equation is going to be, take note of this, our balanced equation is going to be, let me start here. It's going to be C4, H10, let me write the substances first, plus oxygen, giving us CO2 plus H2O. The coefficients will become 2 there, and 13 over 2 times 2 is 13. 4 times 2 is 8, and 5 times 2, the answer is going to be 10. Let's see if this equation is truly balanced. We have 8 carbons there. There is 8 carbons. We have 20 hydrogens. Remember, 2 times times 10, that's 20 hydrogens. And here 10 times 2 is 20 hydrogens. Let's go to oxygens. 26 oxygens here. 13 times 2 is 26. 8 times 2 is 16, plus 10, 26. The equation is balanced. So this understanding is applied for alkanes and alkynes as well. Next, we're moving on to alcohols. So this, I'm going to call it page 3, because that was page 2. Let's move to alcohols. I want to start on a fresh page. All right, let's move on to alcohols. What is our approach? Page 4. Page 4. And this information now, I don't need it. Let me put it somewhere. Next, we're moving on to alcohols. Right. On alcohols, the question again says, balance the following. Combustion. Combustion reactions. Now, let's look at number 1. So number 1, let me write it here. Number 1, we have, let's start with ethanol. So C2H5OH. Remember, general molecular formula for alcohols is CnH2n plus 1 OH. Now this, again, in complete combustion, producing carbon dioxide and water. Let me put up second one, where the number of carbon atoms is an odd number. That's propanol, H7OH. When we start looking at naming of alcohols, this could be propan 1 or it could be propan 2 or. So we just call it by the family name propanol. Combining with oxygen here, producing carbon dioxide in a balanced in a complete combustion reaction producing carbon dioxide and water. Now let's look at the answers to these two. All right, so number one, we have C2H5OH combining with O2, giving us CO2 plus H2O. Now, I have two carbons here. I need two carbons there. Two carbons, two carbons. I have 5 plus 1, 6 hydrogens. I need 6 hydrogens here. By putting a 3 there, I know 3 times 2, it will be 6. Now, carbons balance, 2 carbons, 2 carbons. Hydrogens, 5 plus 1, 6 hydrogens, 6 hydrogens. Oxygens, we go to the right-hand side. That's 4 times 2, 2 times 2 is 4, plus 3 times 1 is 3, and the answer is 7. Now, if you would recall, balancing of alkenes, and alkynes, we would have to divide 7 by 2 and then get the answer here. But there's this oxygen here, shall I say hiding, and therefore we have to subtract 1 from 7. So 7 minus 1, the answer is 6. Now it is the 6 that must be divided by 2, that 2 to get a 3, and that's the one we need here. Now let's check if this is balanced. 2 carbons, 2 carbons. 6 hydrogens, 6 hydrogens, 3 times 2 is 6. Oxygens, 6 oxygens plus 1, 7. That's 3 times 2, 6 plus 1, 7. What is 2 times 2, 4, plus 3, 7. So oxygens are also balanced. The equation is balanced. Let's move on to the next example, number 2. Example number 2, we have C3H7OH reacting with oxygen, producing carbon dioxide plus water. We're dealing with complete combustion reactions, but in complete combustion reactions, the same procedure applies. Now, let's check here. So now, in example number 2, we have 3 carbons here. We need 3 carbons there. And we have 8 hydrogens, 7 plus 1, 8. We need 8 hydrogens there. Put a 4 there. 4 times 2 is 8. Let's go to oxygens. We go to the right-hand side. 3 times 2 is 6, plus step number 1. 4 times 1 is 4, and the answer is 10. Remember, we're dealing with alcohols now. This one here is hiding, so we're going to say 10 minus 1. So our step number 2 is going to be 10 minus 1. This one is that oxygen in the alcohol molecule, and our answer is 9. So we're going to take 9 divided by 2. This must come here. And like we did for alkanes, we have to multiply the whole equation by 2 to get rid of that fraction there. And therefore, our balance equation then becomes C3H7OH plus, I'm going to write the numbers with a red pen, O2, giving us CO2 plus H2O. Let's put in the coefficients now. Here we have 2. 9 over 2 times 2 is 9. 3 times 2 is 6. 4 times 2 is 8. Let's check if this equation is balanced. 6 carbons, 6 carbons balanced. Then we're moving on to, let's check. 2 times 3, 6 carbons, 6 carbons. Hydrogens, 7 plus 1, 8 times 2, 16. 8 times 2, 16 hydrogens. Oxygens, 2. Remember, this 2 stands for the whole thing. So 2 oxygens plus 18. 9 times 2 is 18. Plus 2, 20. 6 times 2 is 12 plus 8, 20. So yes, the equation is balanced. Now, alcohols are taken care of. I'm moving on to carboxylic acids. And you'll see that the procedure basically is the same. We're moving on to carboxylic acids. Now, carboxylic acids. We're dealing with different types of homologous series and carboxylic acids line. So again, let's look at examples. Of course, the question says balance the following combustion reactions. Or equations. One would say balancing equations. Well, that's fine, but equations are describing chemical reactions. So number one, we're dealing with carboxylic acid. So let's start with one where the number of carbon atoms is an even number. So C2H, remember 2 times 1, 2 times CN, H2N plus 1, COOH for carboxylic acids. So N, in this case, N is 2, and there we must have 5, and then COOH. The name of this is propanoic acid because we have 3 carbon atoms reacting with oxygen, and what we get is carbon dioxide plus water. We're again dealing with complete combustion. Maybe in example number 2, I should talk about incomplete. So you see that procedure is basically the same. Let's talk about, let's say, pentanoic acid. It will be C5. This will be hexanoic acid, C5. H, 2 times 5 is 10, plus 1 is 11, and then COOH. That's hexanoic acid. Why is it hexanoic acid? Because it has 6 carbon atoms. So hex 6, pent 5. Right, combining with oxygen, let's say that we produce carbon monoxide plus water. So this is incomplete combustion because remember, the products of incomplete combustion are either carbon monoxide and water or carbon and water. Now let's look at the answers. Number 1, we have C2H5 COOH reacting with oxygen, giving us CO2 plus H2O. Let's balance this. We start with carbons. 3 carbons. We need 3 carbons here. Hydrogens. 5 plus 1, 6 hydrogens. 6 hydrogens. 3 times 2 is 6. Next, oxygens. Remember, it's carbons, 3 carbons. Hydrogens, 5 plus 1, 6. 3 times 2 there, it will be 6 hydrogens. Oxygens will move to the right again. 3 times 2 is 6 plus 3 times 1 is 3. The answer is 9 in our step number 1. Step number 2, we are not going to just divide that by 2 because there are 2 oxygens here hiding, shall we say. So we are supposed to subtract 2 now, and the answer is 7. Remember, for alcohols, we're subtracting 1 because there was only 1 oxygen in the molecule, in the alcohol molecule. In this case, we have carboxylic acid. We have a carboxylic acid, and there are 2 oxygen atoms in the molecule. So we subtract 2. Now, in the third step, we take 7 divided by 2, and that must come here. Now, multiply the whole thing by 2. You're going to get this one here. C2H5 COOH. O2, we're adding that, giving us CO2 plus H2O. Let's put in the balance the coefficients. There will be a 2 there. 7 over 2 divided by, multiplied by 2 is 7. 3 times 2 is 6. 3 times 2 is 6. Let's see if this is balanced. That's 4 carbons. 2 times 2 is 4. 2 plus 1, 3 times 2, 6 carbons. Or you can also say 4 plus 2, 6 carbons. And here you have 6 carbons. Let's go to hydrogens. Forget about this for a moment. 5 plus 1, that's 6 times 2, 12 hydrogens. 6 times 2, 12 hydrogens. Let's look at oxygens. Forget about this for a moment. We have 2 oxygens times 2, that's 4. Plus 14, that's 18. This is 12. 6 times 2, 12 plus 6, 18. equation is balanced. Let's move on to the next one. Number 2, we have C5, and then we have H11 COOH combining with oxygen O2, giving us CO plus H2O. Let's put in the numbers. Carbons, 5 plus 1, 6. 6 carbons. Hydrogens, 11 plus 1. There's 12 there. We need 12 hydrogens there. 2 times 1, 2 times 6 times 2 is 12. Oxygens, remember carbons, 5 plus 1, 6. 6 carbons. Hydrogens, 11 plus 1, 12. 12 carbons there. 2 times 6 is 12. Oxygens, we move to the right hand side. So we have 6 here plus 6 there. Remember here it's CO, so there are 6 carbons and 6 oxygens. 6 plus 6, the answer is 12. In step number 2, we're going to take 12, subtract 2. This is 2 here, and the answer is 10. And we're going to take 10, divide by 2, and the answer is 5. That 5 must come here. This equation is balanced. Let's check if it is. 5 plus 1, 6 carbons, 6 carbons. 11 plus 1, 12 hydrogens, 12 hydrogens, 6 times 2 is 12. Oxygens, 2 plus 10, that's 12. 6 plus 6, 12. The whole equation is balanced. Now, for ketones and aldehydes, the approach is the same. For esters, approach is the same. I'm just going to give one example of ketones and one example of esters. Let's just say here, ketones and esters. Ketones and esters, or esters, whichever pronunciation you prefer. Now, for ketones, we have, let's look at an example here. For examples, one for each. Balance the following combustion equations or reactions. Of course, we're balancing equations. Equations describe reactions. Now, number 1. For ketones, I'm going to start with, let's say we have an odd number of carbon atoms. So it will be 6C3H6O. Remember, for ketones and aldehydes, the number there is always twice the number of carbon. Hydrogen is always twice the number of carbons for both ketones and aldehydes. The only difference is that the smallest ketone must have 3 carbon atoms, whereas the smallest aldehyde must have one carbon atom. We'll talk about these things when we start looking at the 9 homologous series that we focus on in high school organic chemistry. Now, here we're dealing with organic reactions only. So there, combining with oxygen, giving us carbon dioxide plus water. Remember, we're talking about complete combustion mainly. Let me give example number 2, and I'm talking about esters. Now, esters, again, the ratio of carbon and hydrogen is 1 to 2, but for oxygens, there are 2 oxygens there, so we must not forget that. Let's talk about an even number of carbon atoms. So C4H, that will be 8, and O2. Right. Combining with oxygen, again, in a complete combustion reaction. Let's look at the answers. Number 1, we have C3H6O plus O2, giving us CO2 plus H2O. Let's put in the coefficients. 3 carbons, 3 carbons. Let's talk about hydrogens. We have 6 hydrogens here. We need 6 there, so I must put a 3 there also. 3 times 2 is 6 hydrogens. And oxygens, we move to the right hand side. Step number 1, 3 times 2 is 6 plus 3 times 1 is 3. The answer is 9. Step number 1. Step number 2, remember there is this one here again in this molecule, which we must subtract. So 9 minus 1, the answer is 8. And step number 3, we take 8 divided by 2, and this is 4. The 4 must come here. That 2 we're dividing is that 2 there. Now, is it balanced? Let's check. 3 carbons, 3 carbons. Hydrogen, 6 hydrogens, 6 hydrogens. Oxygens, 8 plus 1, 9. 3 times 2, 6 plus 3, 9. So the equation is balanced. Let's move to example number 2, where we're dealing with esters. So this is, you can call it an aldehyde or ketone. So I'm going to say ketone or aldehyde because they're basically, they have the same, like I said, the same ratio there. Aldehyde and esters there. Ketone, aldehyde, and ester. So this is an ester. Now let's look at the balancing of it. C4, H8, O2, combining with oxygen, giving us carbon dioxide and water. Let's put in the coefficients. 4 carbons, 4 carbons. 8 hydrogens, 8 hydrogens. 4 times 2 is 8. Oxygens, we move to the right hand side. That's 8. 4 times 2 is 8, plus 4 times 1 is 4. The answer is 12. Now, notice there are 2 oxygens there now. We're going to have to say 12 minus 2, and the answer is 10. Then we take 10, divide by 2, the answer is 5. That must come here. And I want to say to you that if the number of carbon atoms here is an odd number, whatever you find here would be a fraction. You come here and you do what we've done in the previous examples, and then you find that the equation is balanced. Let's check if this is balanced here. 4 carbons, 4 carbons. 8 hydrogens, 4 times 2 is 8 hydrogens. Oxygens, 10, 5 times 2, 10 plus 2, 12. 4 times 2 is 8, plus 4, 12. So the equation is balanced. All right. In our next lesson, we're going to look at the type of organic reaction number 2, where we'll combine, we'll use discuss one organic reaction or combine 2, because we need to have at least 2 more videos on organic reactions, and perhaps not just organic reactions, but organic chemistry, and see if we can complete it. All right, so we'll see you in the next video.